Okay, so today's notes are on the laws of exponents or the properties of exponents, and it's going to be section 6.1a or unit 6.1a. Our content objective is to use the laws of exponents to simplify expressions, and our language objective is to use the correct terminology to describe the laws of exponents and applying them. So let's jump in with going over what these laws or properties actually are. So I'm going to make a little table here. So the laws or properties of exponents. So over here, I'll put the property or law. And over here, I'll do an example of how to apply or use that law. So the first one we're going to jump in with is, or says that anything to the 0th power is equal to 1, assuming that that number or that base is not equal to 0. So the first one just says anything to the 0th power is equal to 1. So this could be something as simple as like 5 to the 0 is equal to 1, or it could be a huge number. So we'll just use 2017 or 2018. We'll use 18 since it's 2018. To the 0 is equal to 1. Again, anything to the 0th power is just equal to 1. So that's our first property. The next one says that anything to a negative exponent, so if we had a to the negative n, I can rewrite that as a fraction, so as a number over a fraction with that exponent. So I flip it underneath and change the sign as sort of the process, or is the process that we're following. But this more or less says that anything that's negative can be put into the denominator and rewritten as a positive exponent. This comes up again later when we talk about subtraction, or the reason this works I think of as subtraction. But we'll talk about it in a second. For our example, I'm just going to say if we had 3 to the negative 1, we could rewrite that as 1 over 3 to the 1, or just 1 over 3. Or if we had something like 7 to the negative 2, I could rewrite that as 1 over 7 squared, which I could then rewrite as 1 over 49 if I was trying to fully simplify it. So that's a 2 there, just FYI. So those are two examples of how we can use that property. If we keep going, another law or property is if I'm multiplying two numbers with the same base, I can add their exponents. So we've done this previously with our polynomials and foiling, but this just says if I'm multiplying two of the same variable or number, I can add their exponents. So a to the m times a to the n is equal to a to the m plus n. So if we actually use some variables to do that, if I had something like x cubed or x squared times x cubed, I can add those. X to the 2 plus 5, or sorry, 2 plus 3, which is equal to x to the 5th. Same thing works with just real numbers. So if I had 3 cubed times 3, that's the same as 3 to the 1, that'd be equal to 3 to the 3 plus 1, or 3 to the 4th. So if I don't write any exponent, I assume that it's 1. So in this case, I can simplify in that manner, or actually calculate out 3 to the 4th, which would be 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So those are examples for that one. Continuing on, similarly, if I have a to the m over a to the n, and if they're being multiplied, I add them. So it only makes sense that if I'm dividing them, I would subtract my exponents. So if I'm dividing, I subtract my exponents. I'm sure you've done this before as well. But if we have x to the 4th over x to the cube, or x cubed, that would just simplify to x to the 4 minus 3, or x to the 1, or just x. Or you can do it with real numbers. So if I had something like 2 to the 7th over 2 to the 5th, I could rewrite that as 2 to the 7 minus 5, or 2 squared, which is just 4. Continuing. This one we've also done a fair amount with, but if I have a times b to the power of n, I can rewrite that as a to the n times b to the n. And I want to pause here because this is a really common thing I see people mess up on when we review this rule. This only works if what's in the parentheses is being multiplied. If it is being added or subtracted, you need to FOIL. That's why we spend all that time practicing foiling with our polynomial unit. But this I can only distribute my exponent like this if what's being inside is only being multiplied or divided. I can't distribute it if there's things being added or subtracted in the parentheses. This only works when what's inside the parentheses is being multiplied or divided. Again, repeating, only works if what's inside the parentheses is being multiplied or divided. It cannot be added or subtracted and still distribute the exponent. All right, so what this looks like, if I had something like 5x, that whole thing squared, I could rewrite that as 5 squared times x squared, which would be 25x squared. Could also just work with variables. So if I had something like xy to the fifth, I could rewrite that as x to the fifth, y to the fifth. Just as this works for when there's a single number to the first power, I can do the same thing if I have a number to a power. So if I had a to the m, that whole thing to the n, I can rewrite this as a to the m times n. So what this looks like with some real numbers, if I had x squared cubed, that becomes x to the 2 times 3, which is x to the 6th. So if you raise a power to a power, you multiply their exponents. So raising a power to a power means you multiply their exponents, whereas if you're just multiplying two terms that are the same, you add their exponents. Last one, which is another variation of the same idea, is if I'm dividing two terms and raising them to an exponent, I similarly can distribute the exponent because they're being divided, not added or subtracted. So I'd get a to the n over b to the n, which, an example, we could have x over 7 squared, which gives us x squared over 7 squared, which would just be x squared over 49. So these are the laws of exponents we're going to start with today, or the properties of exponents that we're going to work with today. We're going to do one example and quick check of sort of simplifying using a variety of these at once, and that will be it for today's note. So I'm going to flip the page, or an example and a quick check, I should say. So our example I want us to do together to start asks us to simplify and rewrite the expression using only positive exponents. So our first one, we have 5a cubed times negative 3a to the negative 4th. So the first thing I'm going to do is multiply the coefficients. So since I'm multiplying this whole term times this whole term, I'm going to multiply the coefficients, which would give me 5 times negative 3. And I'm also going to multiply variables that are the same. In this problem, it's only a, so I'm just multiplying a. But this would work if I had multiple variables that were not all the same. I'd only be multiplying the variable, or working with laws of exponents with variables that are the same, or combining variables that are the same. So here I have a cubed, or times a cubed times a to the negative 4th. Then I multiply these, I get negative 15. Since I'm multiplying these two terms, they have the same base, I add their exponents. So I have a to the 3 plus negative 4. So if I add 3 plus negative 4, I get negative 15 a to the negative 1. So step 2 was simplify using laws of exponents. So then last thing I do, since I have 15, I have a negative here, I'm going to use another law of exponents, and I'm going to put that into the denominator and change the sign. So if you look back at our table, it's the second law of exponents. So I'm going to flip the page back to a second to show you. This one, if I have a negative exponent, I can put it in the denominator and make it positive. So I do that, and I get negative 15 over a as my final answer. This would be a to the first, but if it's to the first power, you don't need to actually write it out. So that's our answer for that one. We're going to do a quick check. I want you to do the same thing for the following two problems. So for number 1, I have negative 4x to the negative 3, y to the 5th, that whole thing squared. And the next one is a little bit longer. I have a fraction here for you. I have 4a b to the 6th, c cubed, all over a to the 5th, b c cubed. So I want you to use laws of exponents to simplify both of these expressions. Go ahead and try that. I'm going to go over it. So I distribute the 2 into each thing. Since all these terms in here, none of them are being added or subtracted, they're all being multiplied. I can go ahead and distribute that exponent into each one. So I have -4 squared x to the -3 times 2, y to the 5 times 2. So I'm distributing all those exponents. This is 4 would be to the first, or -4 would be to the first, so times 2. So I'm multiplying all the exponents there. -4 squared gives me 16. Here I'd get x to the -6 because -3 times 2 is -6. And here 5 times 2 is 10, so I get y to the 10th. Again, since I have a negative exponent and I want only positive exponents, I'm going to flip that one into the denominator. I get 16 y to the 10th all over x to the 6th. And that is my solution for, or simplified expression for that problem. Here, since I'm dividing, I'm actually going to subtract each exponent. So again, if you are dividing, you subtract exponents. So I have 4a to this, since there's nothing written there, it implies 1 minus 5, b to the 6 minus 1, and c to the 3 minus 3. So I have 1 minus 5, 6 minus 1, 3 minus 3. I simplify that and I get 4a to the -4, b to the 5, and c to the 0. So here, again, I have to flip that one into the denominator since it's negative, so I flip it down and make it positive. Here, anything to the 0th power becomes 1. So I end up with 4b to the 5th over a to the 4th. And that is my solution. All right, make sure you write down any questions, comments, concerns you have on this so we can go over it together in class.